Let us resume some important concepts related to airline fleet planning from last time. Let us start with looking at the various types of performances as considered in the field of civil aviation. There is something called as nominal performance, which is the average performance level of a fresh aircraft which is delivered from either the manufacturer or from anybody who produces the aircraft. Now, this includes all the performance improvements which are incorporated and also in the pipeline. Okay. Then we have something called as FCOM performance or flight crew operating manual performance. This is the performance which is certified from operational calculations. So, this is issued for a combination of aircraft and engine, and as the name suggests, this is something that is certified by the manufacturer. Then you have something called as guaranteed performance. The guaranteed performance is the performance which is proposed by the manufacturer to offset the risks of the airline. So, if the airline has purchased an aircraft based on the information given by the manufacturer that it can travel so much distance under normal conditions with so much payload, and if it does not do that, then there is going to be a penalty clause. So, the three types of performances address three different needs. The guaranteed performance is something that is guaranteed by the manufacturer. The flight crew operating manual performance is for a specific aircraft and engine combination certified for operational calculations, and nominal performance is that of the fresh aircraft. So, over time the performance degrades, and therefore, the nominal performance is the best performance. There are two types of performance which we have to understand. There is the critical performance, which decides the limits of the aircraft's capabilities. When we calculate the critical performance, we assume that the aircraft is absolutely full, the passenger load factor is 100%, the payload is 100%, cargo is 100%, and the ambient wind and OAT are in 85 percentile. But when we calculate the average performance, we look at the capabilities in general operating conditions, and here we assume that the load factor is 75%, the payload is also 75%, the cargo is only 50%, and you are looking at 50 percentile conditions for the ambient wind and the outside air temperature. Okay. Now, the en route conditions which are prevailing, they affect a lot on how the aircraft performance turns out. As the outside air temperature increases, we have lots of negative effects. The engine performance reduces and the climb rate also reduces. Now, to give you an idea, suppose the outside air temperature goes up by 10 degrees at the cruising altitude of 33,000 feet. The effective altitude is going to become 34,300 feet. This is calculated based on at what altitude will the temperature be higher. Okay. And effectively you will have to, you require more energy, right. So, now during climb, as the ambient speed increases during climb, you have increase in the climb angle alpha and the flight path angle also, because of which the ground distance or the distance travelled on the ground to achieve the cruising altitude or to achieve the end of the climb is increasing. So, during cruise, as the headwind increases, you will notice that the fuel consumption goes up because the resistance provided by the headwind leads to higher consumption of fuel, and also the ground speed will reduce because the aircraft will have lower speed, lower ground speed due to the headwind. So, there is a concept called as the equivalent still air distance or ESAD. We should understand what this concept means. This is the ground distance travelled by the aircraft in zero wind conditions. Okay. So, the ESAD is equal to the true airspeed into the ground distance in the presence of a true airspeed divided by the true airspeed plus or minus the wind, where the plus or minus depends on whether it is a headwind or a tailwind. Okay. So, in this formula, TAS stands for true airspeed, GD stands for ground distance. So, let us take an example. If an aircraft is flying at a 500 knot speed and if the ground distance is 2000 nautical miles when the headwind is 40 knots, then the equivalent still air distance is going to be 500 into 2000 divided by 500 minus 40. Headwind is subtracted and tailwind is added. It will be 2174 meters. So, we can notice that because of headwind, the distance travelled is less than what it would be if there was no headwind. Similarly, if there was a tailwind, then this distance would actually be quite different. This brings us to the concept of specific air range or SAR. The specific air range is defined as the distance flown by the aircraft per unit of fuel. Generally, it is measured in nautical miles per kilogram of fuel, but there could be other units also used. The SAR depends on many factors. It depends on how heavy the aircraft is during the cruise. Obviously, if the aircraft is heavier, then the SAR is going to reduce. Similarly, cruise altitude. The higher you go, the lesser drag you encounter because the ambient air density reduces. However, the aircraft has an engine which also loses performance with altitude. So, there is a particular band of cruise altitude at which you have the optimum or the highest value of SAR. Hence, cruise altitude makes a huge difference in the value of SAR for the aircraft and also the cruise Mach number. Definitely, if you are flying at a higher cruise Mach number, you are going to have lower nautical miles per kg because you are going to face higher resistance. Similarly, the ambient conditions also create. So, let us have a look at how the SAR changes with the Mach number. So, depending on the weight of the aircraft, you have any of these lines. The topmost line is essentially for a low weight and the bottommost line is for the high weight. Okay. So, we notice that the SAR is achieving its maximum value at a particular Mach number and then it reduces. So, this particular Mach number which gives you the best value of SAR for a given altitude, that particular Mach number corresponds to MRC, or if you want to achieve maximum range on a given amount of fuel, then the Mach number to fly will be MRC. It corresponds to the maximum range cruise. Notice that the value of MRC increases as the aircraft becomes heavier. These values assume that the cruising altitude is the same and the outside air temperature is the same. Let us now look at the concept of long range cruise or LRC. MRC, as we have just now seen, corresponds to the maximum value of SAR. Now, if you trade off little bit the MRC and fly at a higher Mach number, so if you compromise 1% of the SAR and in return if you go about 3 to 5% faster, that particular Mach number corresponds to the long range cruise or LRC. So, here there is a slight loss in the specific range, only 1%, but you get much better improvement in the Mach number and hence you travel faster. So, the concept of LRC is that as the weight reduces, as the weight increases, you can see this. Having looked at the concept of MRC, let us now look at the concept of LRC or long range cruise. With MRC, you have of course the highest specific range. So, you will travel the maximum distance per kilogram of fuel. But if I agree for a slight trade off, let us say 1% trade off in the SAR value, I can get on this line or any line around 3 to 5% improvement in the cruise Mach number. In other words, I will be able to travel faster at only a 1% loss in the specific range. So, the lines which correspond to Mach numbers at which you have only 1% lower SAR is called as the LRC or the long range cruise. So, let us look at the difference between MRC and LRC. MRC is the most efficient cruise because definitely there is the highest value of the SAR at each W cruise, but it is very difficult to maintain it due to the requirements of keeping the thrust constant. As the aircraft travels, the aircraft becomes lighter and also there are wind disturbances. So, to maintain MRC, the pilot has to constantly adjust the thrust, right. LRC is the trade-off in fuel efficiency and speed. So, this is the most usual cruise strategy that is followed by an airliner. LRC results in a stable cruise flight without necessarily adjusting the throttle. It is almost like self-adjusting. How does it work? Suppose you are flying at the speed corresponding to VLRC or speed corresponding to the LRC Mach number at a particular altitude. For some reason, if that speed decreases, it could be because of the presence of headwind or it could happen because of certain reason. What will happen is that the drag will be reduced, and when the drag is reduced, automatically the thrust also is going to be more than the drag. So, it will accelerate the aircraft to VLRC. On the other hand, suppose the VLRC increases, so the drag will also increase. When drag increases, the aircraft will slow down and come back to VLRC. So, here you do not require constant thrust adjustments and you are only having a compromise of 1%, but much better Mach number. So, you will reach the destination much faster. After all, people fly by aircraft essentially to travel faster. Okay. So, that is why LRC is the most usual cruise strategy, but there are more. Okay. There is something called as minimum time cruise. Now, the definition of MTC is you want to travel in the minimum time from a particular origin to a destination. This could happen because you want to recover from a delay in the previous flight and due to which your scheduling gets compromised. Okay. So, you are late in the previous sector and you want to reach the next sector at the appropriate or the scheduled time. So, you fly a little bit faster. Of course, you are going to compromise on the fuel consumption, but you will be able to ensure that the connection at the hub is not lost or disturbed. So, the minimum time cruise is at a higher Mach number compared to the LRC. Okay. So, here you are trying to save on time by travelling much faster and compromising on the SAR little bit. Now, there are other considerations to be kept in mind. The airline is not bothered only about the fuel cost. Fuel cost, although a major component, is not the only component. In a very long distance flight, if you travel slowly because you want to have higher value of SAR, you are going to pay the allowances or the flight allowances which are per hour for the crew members both in the cabin and in the cockpit. You have to pay more because their payment, one of the important components of their remuneration is the money that they get per hour of flight. So, let us say you travel slowly and in return you have to travel for 3 more hours or 2 more hours, you are going to incur higher costs. Okay. So, the MRC corresponds to the lowest value of fuel cost, but there are also some fixed costs which do not change, but there are also some time related costs which also come down as the cruise speed increases. So, therefore, the total cost is going to be following a slightly different curve, and there will be one particular speed at which you will have the most overall economy for the airline, and that is called as the econ. So, sometimes you do not fly at MRC, you do not fly at LRC, you fly at an econ speed. That econ condition gives you the least overall cost of flight operation. Then there is the concept of cost index. The cost index is the ratio of the time cost and the fuel costs. Okay. So, if we look at the same graph which I showed you earlier, you will find that the point at which the time costs and the fuel costs are intersecting corresponds to the econ, and the cost index can be minimum when you have minimum fuel cost and maximum when you have minimum time cost. So, when you compromise between the fuel cost and the time costs, the cost index can vary from 0 to 100 or even larger values. So, the minimum value of CL or CI cost index will occur when you have focus only on the fuel costs, and the maximum value of CI will occur when you focus only on the time cost, and somewhere in between lies a sweet spot called as the econ, at which the total operating costs are lower. So, if you look at multiple cruise strategies, this is the MRC line, this is the LRC line, this is the minimum time line, and generally speaking the cost index line will be in between MRC and LRC. Okay. So, now let us look at how an airline selects an alternate airport or airports while it does route planning. Now, it may not be possible to land at the destination airport for a variety of reasons. These could be because of poor weather at the destination airport. It could be also because there are some obstructions on the runway. Maybe some incident happened in the by a previous aircraft, because of which the runway is not available, or in some cases there could be animals on the runway which will take time for us to shoo away. Whatever be the reason, if there are some obstructions on the runway, then you can't land at that airport. Similarly, it is very important to keep in mind that you need to select the alternate airport very carefully, and there are many considerations for it. It depends upon weather, depends upon the geography, and also depends upon the presence of the airfields available near the destination airport. So, if you choose a destination airport or an alternate airport near the destination airport, there is a problem because they will have similar weather conditions. So, if you are diverting because of weather conditions, you will have the same weather there most likely. If you choose the alternate airport too far away, then you might have much better weather conditions there. However, you might end up with the maximum landing weight limitations, because you may not have the required amount of fuel to travel to that distance. So, therefore, and also sometimes all runways and all airports cannot handle a large aircraft with a landing weight. Okay. So, you might have a alternate airport far away, so the weather is okay, but it may not be able to handle this aircraft. Either the runway lengths available are less than what are required, or the runway cannot handle such a heavy aircraft. So, the rule of thumb is that we normally choose the alternate airport between 150 to 250 nautical miles from the destination. We do not choose it less than 150 nautical miles, nor we choose it too far away. Now, let us look at reserve fuel, which is an important consideration. Reserve fuel, we have to carry it for a variety of reasons. One reason is that the aircraft may not perform exactly the way it is supposed to, for a variety of reasons. Then there could be errors in the navigation. There could be deviation from the flight plan because you want to circuit bad weather, or there is some airspace closure, or there is some issue due to which you are asked to deviate from the flight plan slightly, but in that process you will consume more fuel. So, you need to have more than what is required for carrying out the mission. The en route weather conditions are a big reason why you need to carry reserve fuel. Now, this amount of reserve fuel is based on the airline policies with certain constraints also imposed by the regulatory bodies, right. Generally, it is taken as a percentage of the trip fuel or the mission time. So, it could be fuel for, it could be 10%, 6%, 15% of the trip fuel, and it could also be a fuel required for a percentage of the mission time. If the flight is say 2 hours, you might say I need to have fuel for another 15 minutes of flight or 10 minutes of flight. Now, reserve fuel constitutes dead weight which we are carrying, but we cannot use it. So, therefore, airlines try to minimize the amount of reserve fuel, but it cannot be made very low because of safety considerations. So, if we look at the EU OPS fuel policy, which is under the AMC OPS 1.255, they have a very interesting policy. Let us say there is an origin airport from where you start the flight, and this is the destination airport where you end the flight. So, the distance DOD is the distance between the origin and destination, and that is the typical flight path. So, now let us look at one particular point along this particular distance, right. So, the reserve fuel that is to be carried as per the EU OPS fuel policy is the 5% of the total fuel, or it could be reduced to 3% of total fuel if you have these conditions. So, the alternate aerodrome can be anywhere in that circle. The circle has a radius of 20% of the distance between the origin and destination, and the center of the circle is located at either 0.25 times the distance or 0.2 times the distance plus 50 nautical miles, whichever is more. Okay. So, you draw this particular circle, and any airport which is inside this circle could be considered as an alternate airport. It could be right on the route as shown here, or it could be somewhere in this particular circle. Okay. And also you have to ensure that you have 20 minutes of flight time or 15 minutes of holding time at the destination. So, this much of fuel you definitely have to carry. Let us look at diversion. Now, diversion is not landing at the planned destination airport, but diverting to another airport because the destination airport is not available for a variety of reasons. There are many reasons, some of them are common and some of them are uncommon. The common reasons are weather. Most significant factor of diversion happens to be weather and poor visibility at the destination airport. Then there are certain other issues like medical issues. If the crew cannot handle an onboard medical issue that arises during the flight, let us say a passenger falls ill and that illness becomes critical and it cannot be handled, there is a life threatening situation and it cannot be handled by either any doctor on board or the crew members, then the aircraft will have to be diverted to a nearby destination. Okay. Then diversion can also happen because of some technical issues with the aircraft which are encountered during the flight, and you might realize that we are not able to continue, it is not safe to continue, so you divert. There could be some uncommon reasons also. For example, there have been cases when because of the disruption due to passengers, we have to divert and land the flight, do not go to the destination, quickly land. There could be rowdy passengers which are a threat to the safety, or there could be some obstructions at the airport. As I mentioned, some stray animals are there which are taking time to be removed. There could be stranded aircraft because of some technical fault, or there could be stranded vehicles. All of these will lead to the obstructions. This is not very common, but it can definitely happen. And then there could be emergencies. Okay? There could be a situation where the planned airport or destination airport is suddenly closed. There could be a strike, or there could be some problem there. There could be a terrorist attack, there could be a hijack, and therefore you need to divert to some other location. Let us look at holding. Now, when you come to land at an airport in the destination, and mostly this happens at busy airports, you may not be able to land immediately, okay, because of traffic congestion, the most common reason, or because of poor weather and you would like to wait for the weather to become better, or because of runway unavailability. Okay. Now, you do not want to divert because they are working on making the runway available. There was a vehicle stranded, that vehicle is being pushed out, or there is snow on the runway which is being removed, or any emergency was there which is being tackled, then you do not divert, you just hold in the air for some more time. Generally, the holding time varies from 30 to 45 minutes. It is based on expected traffic and past experience. So, if you look at all flights which are scheduled at busy destinations, in India for example, flights which are going from Mumbai to Delhi at peak times, early morning, or Delhi to Mumbai, early morning, early evening, late evening, these are the times when we expect congestion. So, you have to build in more time for the mission for hold. During the hold flight, the aircraft is flown in the minimum drag configuration because we want to conserve on the fuel that you consume during hold. It is a waste. Our aim is to minimize the fuel burn. So, we will fly at that flap setting, at that configuration at which the drag will be minimum, because we want to stay up in the air on the least amount of fuel. So, this is how hold patterns are normally encountered. You follow an oval path and you can enter from outside the oval or from inside the oval depending on where you are. An interesting aspect is the island reserves, especially when you operate to islands in the middle of nowhere. You need to be extra careful in carrying reserves so that you do not end up in the ocean. Okay. So, this is very critical if the destination is an island, because you may not have the alternate airport nearby, so you need to have enough fuel. This requires very accurate weather forecast and monitoring, because if you get it wrong, then you may end up with a serious problem that you can't land and there is no alternate nearby. So, generally fuel for 2 hours of flight time is kept as a reserve whenever we are operating to a remote island. Here is an example. Down in the Indian Ocean there is an island called Cook Island or Cocos Island or Keeling Island. Okay. Now, if you look at the Keeling Island, you can see that this is the runway. One side of the island you have this runway. Okay. This is how the islands look. Okay. They have water inside and water outside, and one strip of land available here where they have built an runway. So, here is a close up of the runway at the Keeling Island. So, now if you are going to operate at Keeling Island because of the tourism reasons or any other reason, then you need to carry 2 hours of flight time worth fuel as reserve, which is called as the island reserves. There is a very interesting concept called as reclearance to reduce the amount of fuel you carry for diversion. Diversion happens only once in a while, it does not happen regularly. Okay. So, if you have accurate weather forecast and if the weather conditions are excellent, then you can reduce the reserve fuel by using the concept of reclearance. So, here is the original profile, which is from A to B and with diversion to E as the alternate airport. So, you have mission fuel to go from A to B and reserve fuel to divert from B to E if needed. This is the original profile. Now, when we want to use reclearance, what we do is we create a theoretical profile called as a reclearance profile. Here you are actually planning to flight from A to C at point D, the reclearance point. You are assuming that you will start your descent. So, you travel from A to C, or you have the mission fuel to travel from A to C with the reserve fuel and alternate from C to C1. Okay. Now, the trip fuel from A to C will be less than the trip fuel from A to B because C is nearer. Here you put 5% allowance to divert from to allow. So, 5% of the allowance A to C is added, and then you have diversion from C to C1. Whereas, here in the normal flight profile, you have fuel from A to B, then you have 5% reserve fuel allowance, right, and then you have diversion from B to B1. So, this is how you can get clearance to operate with a little bit less amount of reserve fuel. Then we have the concept of tankering. In tankering, you do not refuel the aircraft at destination airport because the fuel is very costly there. You carry fuel, you pick up fuel at a location. So, if it is a multi-city profile, you pick up fuel only at that place where the fuel prices are low. Okay. So, at destination airport you may not have fuel supply, or it may be required to reduce the turnaround time. If you have multi-leg flights, you do not want to waste time in refueling every time. So, you would like to reduce turnaround time, so you can do not need to fuel each time. Also fuel cost could be high, as I said. So, this is an economic balance to be struck between the price difference of fuel between origin and destination and the value of the payload that is surrendered because you are carrying extra fuel. Okay. Plus, when you carry extra fuel, your aircraft is heavier than normal, so you are burning an extra fuel. Now, if the cost of the fuel at some location is so low that it makes more economical sense to tanker or to carry fuel or buy fuel at that point for the future missions, that is called as tankering. Now, there are many factors in fleet planning which have to be considered. There are marketing factors, there are alliances between airlines, there are economical and financial factors. You need to rationalize the fleet, you need to ensure commonality in the fleet, and more airlines are now trying to manage with the leasing. A look at how marketing affects the fleet planning. So, the marketing department is concerned with keeping an eye on who the airline aims to serve. So, are we a scheduled airline or are we a chartered airline? In a scheduled airline, the commercial risk is completely of the airline, but in the chartered airline it is of the operator who charters the aircraft. So, an airline can give an aircraft to a company, a charter company. So, it operates the aircraft on behalf of the charter company. The risk is all of the charter company. In a scheduled airline, the airline publishes the schedules in advance, whereas in chartered there is no schedule, it is just a one-off type of flight. So, there is a wider variety of purposes which are served when we fly in scheduled airline. There are people who travel to multiple destinations, there are multiple types of people. But in chartered airlines, there are only one type of people and they are traveling for a particular purpose. For example, there could be a cricket team or a football team that wants to take its crew members, its team members, supporting members, all of them, some 30 odd people, from destination A to destination B. So, they will charter a flight, they will not go by scheduled flight because they may not get so many seats on one particular aircraft, and maybe they don't want to mix up with other people, they want to travel individually. So, they will charter a flight. So, that is for a particular purpose, it is not announced in advance. The underfloor in scheduled airlines is used for cargoes, but in chartered airlines we normally do not carry baggage, we use the underfloor for providing passenger services such as the lavatories. But there are also some additional considerations. For example, does it operate under hub and spoke model, because there you will have to offload and reload the passengers very quickly. Does the airline fly at very specific location? Does it fly in controlled airspace completely, or does it also fly in uncontrolled airspace? Okay. Then there are other objectives which could be there, like you might be operating a flight under the public service objectives, in which case the operating cost will be borne by the agency that funds you, maybe the government or the local municipality. So, there you are giving public service, your costs are being taken care by some body, or sometimes you fly for national prestige. For example, when the Prime Minister or the President of a country travels on official business to some other country, they will take an aircraft, and that aircraft is going to be flying with less number of people, but the whole idea here is that we want to travel with national prestige in mind. Now, there are also some alliances which airlines have, and that affects the fleet planning a lot. Alliances are required to increase the market reach and to share the cost so that the overall cost can come down. But there are some difficulties. First of all, there will be delays in joint purchasing because both the parties have to come to an agreement on the rules and regulations. The aircraft configuration could be specific for one particular airline, and the other airline may not necessarily follow that particular model or like that particular configuration, and the manufacturer may be unwilling to change the pricing policies. But there are also some benefits. The benefits are that there are lesser number of restrictions, because when you share your requirements with an alliance, you can have best of both the worlds, and also revenue normally goes up because you are sharing the costs, and there is also a very good operational synergy when you have an alliance. For example, a large airline which operates only from a hub to hub can have an alliance with a small airline that travels from hub to spoke and spoke to hub. So both of them benefit based on this alliance. Then because of this, the productivity increases because you are focusing on a segment for which you are tuned, and other segments are handled by your alliance partners. Now let us look at some economic and financial aspects of fleet planning. Choice of aircraft determine the financial success of startup, especially the new airlines. The ratio of the number of aircraft owned and leased, it controls the investment. Because when you own an aircraft, you have to pay a large amount upfront. When you lease an aircraft, you have to pay a monthly lease. So your cash flow is spread over time and it is not requiring a huge investment upfront. So there is a requirement to do an appraisal of investment for acquisition of the aircraft. We have to look at the rate of returns, rate of investments, and the ROI and the risk. Okay. Then off balance sheet leasing structures manage debt equity ratio. So when you lease the aircraft, you are able to help the bottom line by increasing the operating cost but reducing the capital costs. So if you have more suppliers, you enable a more leverage compared to a single supplier philosophy. Now we come to two important aspects. One of them is fleet rationalization. In rationalization, what we do is, we don't want to operate many different types of aircraft. We rationalize and reduce the types of aircraft that we operate, because this will improve the operating efficiency and reduce the operating cost. So there is a movement towards consolidation. Okay. That means you have a lower propensity to accept innovation. If there is a market segment that requires a different type of aircraft or which can be served by a different type of aircraft better, you can't do that. But you want to look at the cost benefit analysis. Okay. So when you have consolidation, when you want to reduce the number of aircraft types, you have lower propensity to accept AV innovation and lower propensity to implant advanced technology. And now we look at fleet commonality. This is a very important aspect as far as fleet planning is concerned. It really affects the bottom line. Fleet commonality streamlines and simplifies the flying and maintenance of the aircraft. If there are identical cockpits and operating procedures, it is easy for the pilots to get trained, and also almost any pilot that you have can fly on almost any aircraft without any need to match them. So it allows what is called as a mixed fleet flying. Commonality improves the flight experience for everybody on board. Passengers like to have commonality because they want to see the same thing in each of the aircraft that you operate, same power plant. Now Airbus has taken this concept to a very great level. They come up with a concept called as the Cross Crew Qualification, or CCQ. Under CCQ, any pilot qualified on an Airbus aircraft type can fast track the qualification to another aircraft. Okay. So for example, a pilot who is trained on A320 can convert to A330 or A340 or 50 or 80 much easy as compared to Boeing, where it takes much more time. So you are a pilot, you have flown 380 and now you come and then you fly A320 because you are cross Q qualified. So you can see, for example, all the various types of A340 have the same rating. Similarly, all A320s have same rating. So there are these 5 bunches of aircraft. Okay. So, now 350 is an aircraft with 2 engines and 340 is an aircraft with 4 engines. So, if you have a pilot who is qualified on any of the A350 family, and if the pilot wants to operate A340, you require about 11 days of training. Okay. Similarly, aircraft which the pilots which are qualified for the A340 series, they want to fly A350, again it is only 11 days training. And if you want to graduate to a much larger aircraft, you have to require 15 days of training. But if you see, within 7 days you can move from 340 to 320, and within 2 to 3 days you can move from 330 to 340. Okay. So, 330 and 340 are very similar aircraft, 350 is a different aircraft. So, between 340 and 330 the commonality is much better. These similar numbers, the same numbers for Boeing aircraft are much larger. In many cases it goes up to 1 month. Then there is something called as a flight operational commonality. Commonality by design between aircraft types leads to same or similar aircraft handling qualities. Normal procedures are very similar. This is the advantage of having commonality. Process or discipline of the crew for abnormal situations also similar. So, your pilots are tuned to a particular emergency procedure, it will be very similar or same in the other aircraft. Then the crew can share their tasks more easily. This benefits the airline through many aspects. Licensing and training, 2 aspects. So, if you have same type rating, it is called as STR, a single license endorsement for aircraft related sharing same type certificate. As I mentioned, all the 4 categories of A340 are having the same type rating. Then you have common type rating, a single type license for endorsement for aircraft which are related having separate type certificates. So, one can have a common type rating for A330 and A340. Then you have cross crew qualification. As I said, much lesser time and investment required by the airline to train a pilot from one aircraft type to the other aircraft type. You have then improvements in operations. For example, you could have a single fleet flying. You can have one pool of pilots which are flying under a single license endorsement. All of them are available to fly because aircraft is very similar. Or you can have mixed fleet flying. In mixed fleet flying, there is one pool of pilots flying related to aircraft that require separate license endorsements, and you can have one pool here and one pool here. So, currently there is an increased trend towards leasing. For small airlines or carriers that lack the cash needed to buy a few planes, leasing becomes an attractive avenue for acquisition. For example, Air India leases aircraft from LFCO, and Jet Airways used to lease aircraft from GICAS. There are 3 types of leasing: a dry leasing where you get only the aircraft, you use your own manpower. You have wet leasing where you have the aircraft with the manpower, that means the pilots and the crew members, and you also have something called a damp leasing, which is in between. Some part of the crew comes with the aircraft, but some of the crew can be your own crew. Now, there could be operating lease or financial lease. There are 2 different types of lease. Okay. In the operating lease, the ownership of the asset is retained by the lessor at the end of the lease. So, that means you lease the aircraft and then you continue to own the aircraft, because at the end of the lease, the decision is that we are going to buy it. So, here the lessor bears any market risk to its value. Or you could have financial lease only based on the money. Here the ownership passes back to the lessee for an agreed upon sum at the end, and here there is no market risk borne by the lessor. Okay. So, operating cost of maintenance is ideally same for both the types, but depending on the policy of the airline, they can go for an operating lease or a financial lease. The differences are very important. So, in financing lease, the aircraft is owned by the leasing company. The risks and rewards of ownerships are by the person or the company who leases, and responsible for maintenance is also the lessee. The length of lease is most of the useful lifespan. It appears in the balance sheet. In operating lease, the asset is owned by the leasing company and they also bear the risk and reward of ownership. The responsibility of the maintenance and repairs is also for the leasing company if the contract includes maintenance, or it could be outsourced to somebody else. This is normally done in the part of the lifespan, and in the balance sheet it could be on or off depending on the accounting standards used. The classic question that is asked by any fleet planner is, should I upgrade or should I replace? Okay. You have to look at cost of repair versus replacement. Okay. You have to look at the effect of repair versus the replacement on future reliability of the aircraft. How critical is the repair or upgrade to safety? Is the fuel price going to be affected? Will there be noise compliance issues when we upgrade? So, replacement will ensure that the future is taken care. Thanks for your attention.